different ways that we can do math in science. I personally like to have a little song to help me remember the steps. So the way that I'm going to show you today is by using entity, mole ratio, unit, scale. I'm just going to jump straight into showing you worked examples and to explain exactly what I mean by entity, mole ratio, unit and scale. But you can scrub back to this particular slide to use this when you're practicing your questions. So the question a lot of people ask me is, how do I know what calculation I'm doing? Now, if you are doing the mass triangle using a balanced equation, you will be given a balanced equation. That's the first indicator in the question. And when you look at the numbers that you've been given, you will only be given one piece of information, which will be the mass of a substance. So what we can see in here is that we've been given a balanced equation, and the question asks us to calculate the mass of magnesium sulfate produced when 4.9 grams of magnesium reacts completely with dilute sulfuric acid. So remember our song, entity, mole ratio, unit, scale. The first step is we have to identify the entities that they're giving us in the question. So they want us to work out the mass of magnesium sulfate. So I am going to put a box around the MgSO4. And I'm going to use a different colour here and put a box around the magnesium, which formula is Mg. So we write those down, Mg and MgSO4. Please remember to put a box around those. Step number 2 is looking at the mole ratio. Do we have a number in front of the Mg in the balanced equation? No. So that tells us that we only have 1. And do we have a number in front of the MgSO4? No. So that tells us that we only have 1. So far we've done our entity and our mole ratio. The next thing that we have to do is we have to put it in the appropriate unit. The question is working in grams. So what we want to do is change the unit into grams by multiplying by the gram formula mass. Magnesium, how many do we have inside the box? We've got 1 multiplied by the relative atomic mass, which is 24.5. 1 times 24.5 equals 24.5. So we can insert that into our question. On the other side, how many magnesiums do we have inside the box? We've got 1 multiplied by the relative atomic mass, which is 24.5. 1 times 24.5 equals 24.5. Sulfur, how many do we have inside the box? We've got 1 multiplied by the relative atomic mass, which is 32. 1 times 32 equals 32. Oxygen, how many do we have inside the box? We've got 4 multiplied by the relative atomic mass, which is 16. 4 times 16 equals 64. When we add those up, we get a GFM of 120.5. So we pop that in. We stick those in our calculator. So for the magnesium, 24.5 times 1 equals 24.5. And for the magnesium sulfate, 1 times 120.5 equals 120.5. That's us done our preparation. We then look at the information that the question has actually given us. They've given us 4.9 grams of magnesium. Same substance, same site. We put the 4.9 directly underneath the 24.5 and we do our cross multiplication. 120.5 times 4.9 divided by 24.5, and when you pop that in your calculator, you get a mass of 24.1 grams. Again, if we scan this question, we can see that we have a balanced equation and that we've only been given one piece of information, which is a mass of 7 grams, which tells us we're doing the mass to mass balanced equation type of calculation. So remember, entity, mole ratio, unit, scale. The question wants us to work out the mass of nitrogen trifluoride, so we put a box around that in the balanced equation which is given. And it's been produced from 7 grams of nitrogen, which means we have to put a box around the nitrogen in the formula. So the entities that we're working with is nitrogen, which is N2, and we have got nitrogen trifluoride, which is NF3. The mole ratio, what number do we have in front of the nitrogen? We have no number, which tells us we only have 1. And what number do we have in front of the NF3? We have 2, which tells us we have 2 moles of that entity. We then have to multiply it by the GFM. Remember, that is the formula which is given inside the box, not the big number in front of the formula. So nitrogen, N, how many do we have inside the box? We've got 2 multiplied by the relative atomic mass, which is 14. 2 times 14 equals 28. So that is our GFM. Nitrogen trifluoride, how many do we have? Nitrogens do we have inside the box? We've got 1 multiplied by the relative atomic mass, which is 14. 1 times 14 equals 14. Fluorine, how many do we have inside the box? We've got 3 multiplied by the relative atomic mass, which is 19. 3 times 19 equals 57. When we add those up, we get a GFM of 71 grams. We substitute that in. So now what we're going to do is we're going to multiply both sides out. 28 times 1 equals 28 grams. 2 times 71 gives us 142 grams. We look at the question. What piece of information have they given us? They've given us 7 grams of nitrogen. Same unit, same side. We pop the 7 directly underneath the 28 and we do our cross multiplication. 142 times 7 divided by 28 gives us a mass of 35.5 grams. This question's from the National 5 2018 Written 6C. Scanning the question, we can see that we've got a balanced equation and that we've only been given one piece of information, which is the mass. So we're going to do our mass to mass balanced equation type of calculation. Remember, entity, mole ratio, unit, scale. So the things that they're wanting to work with in the question, it's asking us to calculate the mass of methanethanol, which is the CH3SH. So we put a box around that. Produced when 640 grams of methanol, which is our CH3OH, reacts completely with hydrogen sulfide. So we want to write down our formula directly from the balanced equation. So we have CH3OH in a box, and on the other side we have our CH3SH in a box. We then do our mole ratio. There's no number directly in front of any of the formula from the balanced equation, which tells us we have 1 of each. And we then have to put it into the unit by timesing by the gram formula mass. So how many carbons do we have in our formula? We've got 1 multiplied by the relative atomic mass, which is 12. 1 times 12 equals 12. Hydrogen, how many do we have in total? We have 4 multiplied by the relative atomic mass, which is 1. 4 times 1 equals 4. Oxygen, how many do we have in the formula? We have 1 multiplied by the relative atomic mass, which is 16. 1 times 16 equals 16. When we add those up, we get a GFM of 32 grams. So we substitute that in. We do the same on the other side. We have carbon. How many do we have in the formula? We have 1 multiplied by the relative atomic mass, which is 12. 1 times 12 equals 12. Hydrogen. How many do we have in the formula? We've got 4 multiplied by the relative atomic mass, which is 1. 4 times 1 equals 4. Sulfur. How many do we have in the formula? We have 1 multiplied by the relative atomic mass, which is 32. 1 times 32 equals 32. So we have a gram formula mass of 48 grams. We then multiply both sides out. 32 times 1 equals 32. 1 times 48 equals 48. In the question, they've given us 640 grams of methanol. So we do the same unit, same sides. We pop the 640 directly underneath the 32 grams of methanol and we do our cross multiplication. 48 times 640 divided by 32 gives us 960 grams of our product produced. This example is a little bit trickier because we have numbers in front of the formula we're given in the balanced equation. So remember, entity, mole ratio, unit, scale. The question wants us to calculate the mass in grams of carbon dioxide. So we put a box around the formula in the balanced equation. Produced when 32 grams of nonane is burned, which is the C9H20. We write down our entities, C9H20, we put a box around it, and we've got our CO2, which we put a box around it too. Mole ratio, how many do we have of our nonane? There's no big number in front of the formula, which tells us we have 1, but this time we have 9 carbon dioxides, so we have to write the mole ratio of 9 on that side. We now need to calculate the gram formula mass for each side. So for our reactant, for nonane, how many carbons do we have in the formula? We have 9 multiplied by the relative atomic mass, which is 12. 9 times 12 equals 108. Hydrogen, how many do we have in the formula? We've got 20 multiplied by the relative atomic mass, which is 1. 20 times 1 equals 20. When we add those up, we get a GFM of 128 grams. For the carbon dioxide, we're looking at the formula inside the box. How many carbons do we have? We have 1 multiplied by the relative atomic mass, which is 12. 1 times 12 equals 12. Oxygen, how many do we have inside the box? We've got 2 multiplied by the relative atomic mass, which is 16. 2 times 16 equals 32. When we add those up, we get a GFM of 44 grams. We then want to multiply those sides out. 128 times 1 equals 128 grams. 9 times 44 gives us 396 grams. We look at the information they've given us in the question. They've given us 32 grams of nonane, same substance, same side. So we pop the 32 grams directly underneath the 128 grams to do with the nonane. We then do our cross multiplication. 396 times 32 divided by 128 gives us 99 grams of product. This question's from the National 5 2019 Written 5C Part 1. Again, if we scan the question, we can see a balanced equation, and we are only given one piece of information, which is the mass of a substance. This tells us that we're going to do the mass to mass balanced equation type of calculation. So remember, entity, mole ratio, unit, scale. The entities that are given in the question, it wants us to calculate the mass in grams of ethene. So we put a box around ethene in the balanced equation. Required to make 410 grams of cyclohexene. So we put a box around the formula for cyclohexene. We write those down. So we have C2H4 and C6H10. The mole ratio. Do we have a number in front of the formula for ethene? We don't, which tells us we only have 1. And the same goes for the cyclohexene, and we only have 1 mole of those. We need to multiply by the GFM. So we look at the formula inside the box. How many carbons do we have for ethene? We have 2 multiplied by the relative atomic mass, which is 12. 2 times 12 equals 24. Hydrogen, how many do we have inside the box? We have 4 multiplied by the relative atomic mass, which is 1. 4 times 1 equals 4. When we add those up, we get a GFM of 28 grams. The cyclohexene, we do the same thing on the other side. We work out the gram formula mass. How many carbons do we have inside the formula? We have 6 multiplied by the relative atomic mass, which is 12. 6 times 12 equals 72. How many hydrogens do we have inside the box? We have 10 multiplied by the relative atomic mass, which is 1. 10 times 1 equals 10. When we add those up, we get a GFM of 82 grams. When we multiply both sides out, 28 times 1 equals 28. 1 times 82 equals 82 grams. In the question, they have given us 410 grams of the cyclohexene. So this time we have to put it on the right side, same substance, same sides. We're going to do a cross multiplication. So this time we do 28 times 410 divided by 82, which gives us a mass of 140 grams.